Imagine a creature that redlines its biological engine so hard that if you had its metabolism, you'd need to eat like 150,000 calories every single day just to stay alive.
Yeah, and yet this whole creature is wrapped in a feathered package that weighs less than a nickel.
Right. Well, today we are taking a deep dive into a massive scientific synthesis on hummingbird biology, along with some just released 2026 migration data.
Exactly. And our mission for you today is to basically give you a shortcut to understanding this extreme biological engineering and, to share the actionable ways you can help them survive what's shaping up to be a pretty bizarre year.
Okay, let's unpack this. Because, 150,000 calories, how does an engine like that even function?
Well, to really grasp how extreme it is, you have to look at how they fly. A hummingbird doesn't just flap its wings down to push air. It actually flips its wings upside down at the shoulder joint on the way back up.
Wait, upside down?
Yeah, so they generate lift on the upstroke and the downstroke.
So they're essentially just treading water in midair.
Pretty much. And it's the most energetically expensive muscle work in the vertebrate world. To pull that off, they burn pure sucrose, so carbohydrates, for that explosive hovering flight. But the brilliant part is how their bodies switch gears.
Right, because you can't just run on sugar forever.
Exactly. When it's time to fly long distances, a chemical trigger in their cells recognizes the shift in energy demand. It immediately blocks the body from burning sugar and forces it to oxidize stored fat instead.
An instant built-in switch to lipid endurance mode? That explains how they don't just run out of gas over the ocean.
Yeah, that fat-burning mode is literally the only reason the rufous hummingbird can migrate 3,900 miles, or why the ruby-throated can cross the 500-mile expanse of the Gulf of Mexico.
Which is a 500-mile flight over open water.
With zero breaks, no snacks, just continuous flying with a heart rate pounding at like 1,200 beats per minute.
That is just mind-bending. But wait, if an adult bird has to rely on this highly specialized fat-burning trick just to survive, what about the babies? They're the size of a dime.
Right, they aren't born with fat reserves. So you actually cut out the sugar completely. The mother feeds them a regurgitated diet of small spiders and insects.
Oh, wow. Bugs, not nectar.
Right, because nectar won't build muscle. The babies need the dense amino acids from protein to rapidly construct those massive chest muscles.
Okay, so it's protein for the chassis, and then sugar for the gas tank later. And she's keeping them in a nest made of spider webs.
Harvested spider silk, yeah. It is a total structural marvel. The silk is profoundly elastic, so the ping-pong ball-sized nest physically stretches outward as the chicks grow.
That is wild. So we have this delicate timeline, they hatch, bulk up on bugs, and hit the sky. Yeah. But the 2026 citizen science data shows a serious glitch in that schedule, right?
A major glitch. They are arriving 1 to 2 full weeks early because of shifting climate patterns.
And, just to be clear to everyone listening, we are just impartially reporting the data here, but arriving early means the native flowers they rely on haven't bloomed yet.
Exactly. They are showing up to an empty pantry, which makes artificial backyard feeders a critical lifeline right now.
Okay, but wait. If we're putting feeders out early to help them, shouldn't we take them down in the fall? I've always heard that keeping them up traps them here in the cold because they think food is still around.
That's a surprisingly persistent myth. Their instinct to migrate is driven by photoperiodism, which is the predictable changing ratio of daylight to darkness. Food doesn't dictate it.
Oh, really? So a feeder won't make them stay?
Not at all. It actually provides crucial late-season fuel for juveniles finishing their molts before the long flight.
Good to know. So if we are going to supplement their food, what is the actual science behind doing it safely? Because I know the standard is a strict 1 part white cane sugar to 4 parts water ratio, but people, they always want to get creative with honey or brown sugar.
Do not do that. Doing that will trigger a fatal metabolic crash. Brown sugar contains heavy metals like iron. And while humans process that fine, a hummingbird's rapid-fire metabolism accumulates those metals instantly.
Which destroys their liver, I'm guessing.
Exactly. And the same goes for the chemical compounds in red dyes. Just stick to plain white sugar.
Okay, stick to white sugar, and once we've fed them, we have to keep them from flying into our windows.
Yes. The most effective method in the research is applying a 2x2-inch visual grid on the exterior of your glass.
The outside of the glass.
Right, on the outside. It breaks up the reflection and signals to their brain that the gap is simply too small to fly through before they strike at full speed.
Awesome. So, for everyone listening, you now have the exact blueprint to turn your backyard into a safe haven for these extreme athletes. Strict white sugar water absolutely no dyes, and protect the flight path with exterior window grids.
It makes a massive difference.
It really does. But here is a final thought to chew on. Because hummingbirds consume so much raw sugar, their baseline blood sugar levels would cause instant fatal organ failure in a human.
Yeah, researchers are actually sequencing their metabolic enzymes right now to figure out how their biology handles that toxicity without damage.
Just think about that. If science can decode how a bird the size of a nickel survives sky-high blood sugar, their tiny biology might just hold the key to curing human metabolic disorders like diabetes. Keep that in mind the next time you hear that tiny hum outside your window.